Welcome to this explainer. Today we're going to explore this really cool idea, the architectural metaphor of data. Think of it kind of like building a digital house. Before you pour the concrete or put up the drywall for a modern application, you absolutely need a precise structural blueprint to ensure everything holds together. Let's find out exactly how software engineers draw up those plans to build a highly structured home for our modern data.
All right, so here's our game plan for today. 1. Taming the data chaos. 2. The database solution. 3. Blueprinting with diagrams. 4. Entities, attributes, and relationships. And finally, 5. Some real-world case studies. Let's jump right in.
Part 1. Taming the data chaos. The messy reality of file management.
We've all been there, right? Digging through isolated, messy folders, trying to find that one specific file is an incredibly frustrating, almost universal nightmare. Well, the first major symptom of all this chaos is what we call data redundancy. This is basically a fundamental flaw where the exact same piece of information is stored in a bunch of different places. Imagine a university where a course book's chapter names are saved in one file for the printing department and then needlessly duplicated in a totally separate file for the royalty department. It's just a massive, chaotic waste of storage space.
And it turns out that redundancy immediately threatens our next big concept, data integrity. Data integrity is all about the correctness and consistency of your information across the whole organization. Let's say our author from that previous example gets a new academic title, like going from doctor to professor. If that title gets updated in the chapters file, but someone forgets to update it in the addresses file, boom, we have conflicting information, we've totally lost data integrity. To actually fix this, we have to completely flip how we view our information. We have the physical view, which is literally just how data sits on your computer's storage hardware. But what's really fascinating here is the need for a logical view, which is how we as humans logically arrange and actually work with that information. We desperately need a better logical approach to organize all this business chaos.
Moving on to Part 2, the database solution, bringing order to the digital universe.
So, this brings us to the technological heroes of our story, Management Information Systems, or MIS. An MIS is this brilliant computer-based system that retrieves, extracts, and integrates data from all those chaotic sources. It kind of acts like a secure traffic cop. It ensures that every manager across different departments can access shared databases from one central place, all governed by strict authorization controls.
When you actually stack up a traditional file management system against a relational database management system, the difference is literally night and day. A relational database essentially acts like a massive, highly structured spreadsheet that multiple people across an organization can update at the exact same time without ever losing that precious data integrity.
Now, getting to that perfect database is a literal 6-step engineering process. It kicks off with analyzing requirements, then moves through conceptual design, logical design, schema refinement, physical design, and finally ends with building the app and its security. But for this explainer, we are zooming in heavily on Step 2, creating the conceptual blueprint.
Part 3. Blueprinting with diagrams, drawing the plans before building the software.
It turns out, before writing a single line of software code, engineers map out the entire business domain using the entity relationship model. It's this completely visual language using 3 distinct shapes. Rectangles represent entities, ovals represent attributes, and diamonds represent relationships.
Part 4. Entities, attributes, and relationships, the foundational building blocks of data.
Okay, let's see how this all builds by breaking down these components. We'll start with entities, which basically come in 2 flavors. A strong entity operates totally independently. Think of a hospital patient. But a weak entity, which is usually shown with a double rectangle, depends entirely on a strong entity to even exist. Take a bank account, for example. It literally can't exist without being tied to the specific bank it belongs to.
Next up, we have attributes. These define the actual properties of our entities. They can be simple like a salary, or composite, like a name that breaks down into first and last. They can be multi-valued, like a person having multiple phone numbers. They can even be derived dynamically on the fly, like calculating someone's age from their birthday. But absolutely crucial here is the key attribute, like an employee ID, because that's what uniquely identifies a specific instance of an entity.
Finally, we have the diamond shape. This visually shows how these entities interact with one another. A classic example is a works-in relationship. This acts as the bridge connecting an employee entity over to a department entity.
So, how does all this look when it's actually applied in the real world? We've covered a lot of abstract computer science theory so far. Let's pause, transition directly into our concrete final phase, and see exactly how these shapes solve actual business nightmares.
Part 5. Real-world case studies. Putting database theory into practice.
This theory perfectly illustrates why we need these systems, which brings us to a fascinating case study involving the Faculty of Open Education, or AOF. Just to give you an idea of the sheer scale of AOF's nightmare, they had to manage 278 different kinds of course books, and they needed to track the specific addresses of 735 different authors. Without a centralized blueprint, the sheer absurdity of manually tracking those 735 author addresses across different, isolated departments was causing massive data redundancy and integrity issues.
By applying the exact principles we just learned, AOF translated their logical blueprint into a complex relational model, utilizing 18 distinct connected data tables. Books, authors, publishers, and courses are all perfectly linked together. It's like a giant puzzle coming together.
And because that back-end blueprint is so flawlessly organized, the underlying database securely powers a really user-friendly application interface. Staff members who know absolutely nothing about coding can just click buttons on a menu to track royalties, monitor book storage, and generate custom reports. A real game changer.
We see that exact same success in a hospital setting. Think about a single patient's complex journey, from getting an entry card at the front desk, to being assigned a room, to being tracked by regular doctors and doctors on call, all the way to an operating theater. That entire journey is flawlessly managed through these relational tables. It ensures that critical, life-saving data is never redundant and always perfectly accurate.
Well, that brings us to the end of this explainer. It's kind of wild to think that all the complex software we rely on every single day starts with just rectangles, ovals, and diamonds. I'll leave you with this to think about. If your life was mapped into a database blueprint right now, what would be your strongest entity, and what would be your most complex relationship? Keep learning, and I'll catch you in the next one.